This lesson is related to quadratic equations, and it is about a value called the discriminant. The discriminant is b squared minus 4ac. It is the discriminant of a quadratic equation. It does not give you the solutions to the quadratic equation, but it does tell you how many solutions and the type of solution. It helps you discriminate between what kind of answers you're going to get. I hope you recognize that it is a piece of the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. The expression under the radical is the discriminant because that quantity tells you whether you have two real solutions, that's if it's a positive number, one real solution, that's if it's 0, or two complex but not real solutions if it's negative. So if this quantity is positive, you'll get two real answers. If this is 0, then you do not have the plus and the minus to give you different numbers, and you only get one answer. We had one of those in one of the earlier lessons. If this quantity is negative, then this piece of the answer will be imaginary, and so they say it will be complex, not real. All right, so let's take a look at some quadratic equations and evaluate just this expression. It says, use the discriminant to determine the number and the type of solutions of the quadratic equation. It has x squared minus 9 equals 0. All right, in this quadratic equation, a is 1, the coefficient of x squared. B is 0 because there is no plain old x term. And c, the constant, is negative 9. So if I have b squared minus 4ac, that's going to be 0 squared minus 4 times 1 times negative 9. That gives me 0 squared is 0. Negative 4 times 1 times negative 9 is positive 36. So the discriminant is 36. That is a positive value. And when it's positive, which of these is true? Two real solutions. It does not ask you what they are, but you do find out that you will have two real solutions. All right, let's look at the next one. We have 3x squared plus 6x is equal to negative 3. You can't identify a, b, and c until it's equal to 0. So we have 3x squared plus 6x plus 3, when it comes over, is equal to 0. A is 3, b is 6, c is 3. So if I evaluate b squared minus 4ac, that's going to be 6 squared minus 4 times 3 times 3, which is 36 minus 36, which is 0. All right, when it is 0, that means that you have a single real solution. And if you don't have these written down, you probably want to go back, pause the video, and write these down. All right. This one I have 3x is equal to negative 4x squared plus 2. You could do it two different ways. I choose to add 4x squared to both sides and subtract 2 from both sides. That gives me positive 4x squared, positive 3x minus 2 equals 0. You could have gone the other way. You would get the same result. All right, b squared minus 4ac is the expression for the discriminant. So it is, well, I guess I should have taken a moment. A is 4, b is 3, c is negative 2. So b squared is 3 squared minus 4 times 4 times negative 2. That's 9. I have a negative times a positive times a negative. So that's going to give me plus, and what would that be? 1632. Add those together for 41. That's a positive number. Because the discriminant is 41, that means that I have 2 real solutions. We have one more. 4 is equal to negative 5x minus 5x squared. I really like my x squared term to be positive, so I'm going to add 5x squared. I'm going to add 5x. So I end up with 5x squared plus 5x plus 4 is equal to 0. So a is 5, b is 5, c is 4. So b squared minus 4ac, that's 5 squared minus 4 times 5 times 4. That's going to give me 25 minus 80, which is negative 55. The discriminant is negative 55. What really matters is that it's negative. When it's negative, I usually think that the answers are imaginary, but you're really supposed to call them complex, not real. Okay, they will have an imaginary piece in them. So I think we've seen just about one of everything. If you chose to bring the 4 over here and have all of those as negatives, you'll still get a negative discriminant for this. So work on discriminant.